We are through with sampling distribution till now. You remember we discussed in sampling distribution parameter and statistic. Parameter are the measures that we calculate from the population. For example, if we take the average of each and every observation in the population, that is a parameter mu, and a sample is a part of the population. Any measure we calculate from the sample is a statistic. Now, with the help of statistic, any observation we calculate from sample, for example, x bar or variability of the sample, our objective is to finally have certain inferences about the population, because final target is having some inferences about the population by generalizing the information we gather from the sample. So, hence what we are doing here is, after having a suitable sample with us, by applying the best possible sampling technique there, we would like to have certain estimation about the population parameter from the sample we have gathered. Estimation we apply in every day to day life. For example, even crossing the road, we estimate the speed of the vehicle approaching us. We estimate the distance between the vehicle and ourselves, and then we also estimate our own speed, and then we take a decision whether to wait, whether to walk to cross the road, or whether to run. So, that is a quick estimation. In organization also, we have to apply so many estimation at different situations, and it can equally impact us, like it may impact us while crossing a road. So, under estimation in this chapter, we have certain objectives. We would like to study how to estimate certain characteristics of population from the sample. We will try to learn various strengths and shortcomings of point and interval estimation. I will explain what is point and what is interval estimation, and we will also like to study how accurately our estimates really are. We will try to learn how to use t distribution, because most of the time when our sample size is greater than 30, like we discussed in sampling distribution, then we can apply using sample limit theorem. We can assume that it is normally distributed, and we can apply z test. Now, when the sample size is not more than 30, it is less than 30, then how we can calculate estimate and how we can apply estimation there, that also we will study in addition to z distribution. There are certain terms, the basic terms that we use under estimation. Estimation, I hope we understand, is a procedure, is a process by which we assign certain numerical values to the population parameter based on the information gathered from the sample itself. For example, if we look at the Paul's opinion. So, in Paul's opinion, we only study a sample, and then from that sample we may try to understand how many would like to favor one party, how many would like to favor another party, how many like to favor third party, and based on that sample information, say we take information from 1000, and based on that 1000 people's information, we try to generalize that information to the complete particular area. So, that complete process of selecting the sample, gathering information, then allocating those information received from the sample to the parameter is estimation. Estimator is a sample statistic used to estimate a population parameter. For example, if you are talking about the average of the population, then you only look into the average of the sample, then x bar will be an estimator of the population parameter mu. An estimate would be a specific observed value. To understand it more, say if we want to understand the average marks scored by students in a particular college, then if we are not looking into the complete data, we only gather information say from 50 to 60 students, and having the average marks scored by 50 to 60 students, say we try to have certain estimate about the population parameter. Suppose the average marks scored by those 50 to 60 students is say 7.5 as an SGPA. So, that SGPA would be x bar, that would be representing for the population parameter. So, here x bar is an estimator, 7.5 is an estimate. I hope that is clear, that numerical value 7.5 is an estimate, that statistic sample statistic x bar is an estimator, and that complete process of doing this is estimation. Now, whenever we have a sample, we can have an estimate about the population parameter. So, hence we can have different types of estimates about the population parameter, because there can be number of samples. So, how to decide whether our sample estimate is a good estimate or not. So, to finally conclude that whether it is a good estimate or not, there are certain properties, certain characteristics it must satisfy. Those include unbiasedness, efficiency, sufficiency and consistency. Unbiasedness means it should be objective in its approach, there will not be any biasness. To understand the unbiasedness, unbiasedness is if the expected value from that x bar is equals to mu, then that will be unbiasedness. That is the difference between the expected value of the estimator and the true value would be 0. For example, if we have x bar from a sample and then from another sample, if we have another x bar, say x2 bar, x3 bar, x4 bar, xn bar. So, we have say n samples, we have n averages. Now, if we take average of all those n averages, and if that average is equals to mu population average, then that is called unbiasedness. Then second characteristic required is efficiency. Here efficiency means the variability should be minimum, the smallest mean square error, that is how well the estimator does in predicting. We would like to have that estimator as efficient, which has the smallest squared around the true value. Then efficient would be that unbiased estimator that has the smallest variance. Then moving to the consistency part, efficiency is repeated here from the last. Consistency says that sample is so consistent that with increase in the size of the sample, the variability decreases. In efficiency, we are not increasing the sample size, we are only talking about the single sample, single estimator, and that has smallest variance would be efficient. Consistency means if we keep on increasing the sample size, if the variation of the estimator from the true population decreases, then we will call that estimator as consistent. Sufficiency talks about the information that we can extract from that sample. Here a particular sample would be called sufficient enough if the information that we can gather from that particular sample is the maximum in comparison to any other sample, that it gives all the information about the population parameter, no information is left. So, these are the four characteristics we need to keep in mind to have a better understanding. Let us have a little graphical approach to understand this. For example, unbiasedness. So, a sample is called unbiased if it is expected mean is equals to mu. Now, the average of this lies at mu value. So, we will call this as unbiased, mu is in the center na? Whereas, in this case the average does not lie at the mu value. So, this is a biased estimator. In the same way, if the average lies on somewhere here, the central point, then that will also be a biased one. It will only be an unbiased if the average lies at mu. Efficiency. Efficiency means the variability should be minimum. Now, if we look at the sampling distribution of mean, this B graph is little greenish color is a graph of the sampling distribution of mean, and the another one is the normal curve of sampling distribution of median. Now, if we look at the variability, it is clear from these two, the variability of B is significantly lesser than the variability of A. So, sampling distribution of mean is more efficient than sampling distribution of median. So, the variability data is having less variability in this case than in comparison to in case of median. Then consistency says our estimator is consistent. If we increase the sample size, the variability reduces. Initially, if the sample size is say A, say 10, and variability looks like this, the normal curve, and if you increase that sample size to say 30 or 40, then the variability reduces. If that is the case, then we will call our estimator as a consistent one. It is reflecting consistency. After understanding the basic characteristics, those are most important for a particular estimator to be good estimator, we move to the types of estimation. Types of estimation we can categorize into point estimation and interval estimation. These are the two types. In point estimation, here we assign a single statistic to provide as an estimate of the population parameter. For example, when you were saying the average marks scored by students in a say a campus of 2000 students, we studied marks of 50 to 60 students, say 60 exactly, and then we came to know that their average marks are 60. Sorry, average marks of 60 students is 7.5. I was discussing just now 7.5 SGPA. Now, that 7.5 if we assign to the average marks of the complete college, that 7.5 would be a point estimation for the average mark of college students. That is point estimation. Whereas, so it is quite likely that that may not be correct, because there may be certain variability. It may be little more than 7.5 or it may be little less than 7.5. Hope you agree to this. So, hence that is a disadvantage of point estimation. To have a better confidence about our estimation or our estimate, we use interval estimation. In that interval estimation, we try to have a particular range to estimate the population parameter. So, what we do, say our average here is 7.5. Now, to the left of this we take something on marginal on the left side, something marginal on the right side, something more than this, something less than this. So, that particular range, say 7.5, we may say the average marks of that particular campus is between 7 to 8 SGPA, semester grade point. So, that 7 to 8 range will have more confidence in concluding the population average of that particular campus. So, hence that more confidence is what is a probability attached. So, how much confidence we can have that particular average value, that also we will discuss. So, in this case the confidence brings more accuracy to the estimation. We can have more detailed understanding of point estimation here. So, point estimation is also a form of statistical inference. We will try to have certain inference about the population parameter. So, we use the data from the sample to compute a value of sample statistic that serves an estimate of a population parameter. We refer to as x bar as the point estimator of the population mean mu. So, x bar is a statistic, right? It is an estimate, like we are discussing in estimation, estimate and estimator. So, x bar is what? If we just go back and look it again, estimator is a sample statistic. So, x bar is an estimator. The value assigned to this 7.5 will be an estimate. Then S is also a point estimator of the population standard deviation. P, sample proportion, is a point estimator of the population proportion P. Now, to have complete understanding of this, say we have a sample from simple random sampling. We discussed, say here we discuss marks scored in gate examination. Suppose the parameter value, say you take each and every student who appears in a gate examination, say they have scored 800 marks. We collect a sample of say 100 students. the marks scored by them is say 875. So, point estimate is 875. So, the variability in population is 80, then 80 is population parameter. From that 100 students, if the variability sample standard deviation is 75.5, so it's an S is an estimator of sigma, S is an estimator, 75.2 would be an estimate. Then again moving to population proportion, say population proportion particular city, you are taking a sample, say 0.72 is the proportion of students from particular area or particular city, that is for population. And from the sample, if your 0.68, 68 students out of 100 is the contribution to that particular area, so this will be a sample proportion. So, again this is an estimate, a numerical value is an estimate, this sample statistic is an estimator, and what we are estimating with the help of these sample statistic, we are estimating mu, sigma and p. I hope that is now very much clear to you guys. Moving further to interval estimate. So, as we discussed in the beginning, is describes a range of values within which a population parameter is likely to appear. So, we construct this using point estimate, like we were discussing, to the point estimate something to the left, something to the right. So, we to have that something to the left, something to the right, we call that as marginal error. To define that marginal error, we will be needing standard error, which we discussed in sampling distribution, and corresponding probability, how much confidence we can have. I hope you remember that standard error. Try to have a quick review what standard was, standard error was. We will be using that again and again. I repeat here, standard error is the variability of the sampling distribution, variability of the sampling distribution. In case of mu, that standard error was sigma by root n and so on. Again, the probability that we associate with an interval estimate is called the confidence level. The confidence interval is the range of the estimate we are making. The confidence limits will be a lower and upper limit. Please go through this yourself. It is expected that high confidence level seems to have high degree of accuracy, but that will not be true. We will discuss it again. High confidence level means our area would be more wider to accept the significance of x bar in a particular situation. We will discuss this again. 95% confidence interval means that if we select many random samples of the same size and calculate a confidence interval for each of these samples, then in about 95% of these cases the population parameter will lie within that particular interval. So, here confidence interval means our confidence interval will be, this will be a sort of acceptance region, and outside this will be a rejection region. So, if 95% of the time population parameter lies in this, means our estimate is 95% confident. We can have first a quick view of this acceptance and rejection. Like 95% means these boundaries from this negative value up to this positive value, this total area is 95%. So, 95% of the time a population parameter is lying in this range. So, we will say our confidence is 95%, hence rejection part is in total 5%. 2.5% on the left side and 2.5% on the right side. I hope this is clear now, the confidence part. Once that probability, confidence is what? Probability, how much confident we are, 95%, 90% or 99%, and even quite more than that, sometimes accuracy is needed. Then how we can define the interval estimate? Point estimate is just x bar value is a point estimate for mu, small p value is a point estimate for capital P. Now, how we can define the interval estimate? So, interval estimate we will define with the help of statistic only. So, that x bar will come here. We will be having two values for interval. One is the lower limit, left hand side value, upper limit. Upper limit would be statistic. Z here represents the probability, how much confidence we have, Z value corresponding to it, and standard error. If we are discussing about x bar, so what is the standard error of x bar? In case of proportion, standard error will change. In case of small sample also, standard error may change. So, you know that standard error is the variability of the sampling distribution. So, we will be using that Z into standard error, statistic plus it and minus it. Now, this Z into standard error, we are naming it margin of error. So, how much margin of error we can afford to the left side and to the right side. For example, here this is a general formula to have it specific. In case of mean of large sample, this should be x bar here. Please read this as x bar plus Z into sigma by root n. This will be upper confidence limit. Now, here standard error is sigma by root n and x bar minus Z into sigma by root n. So, again it is, and in case if our population is finite, you studied finite population multiplier. If our population is such that it is not possible to have more than 30 size of sample, 30 samples out of it, then we may need a finite population multiplier and then we can define standard error. So, again role of standard error is very important. So, I recommend that you please have complete understanding from sampling distribution and various situations where sample standard error is defined, that will be used here. So, hence this is very important here. Here this is statistic, sample statistic in the center, interval estimation of x bar we are talking about. So, margin of error on the left side, this is the probability we have. Probability, I hope you remember, in case of 95% area, in case of 95% area as a confidence of acceptance. So, if this is 95%, you remember it is a symmetrical curve. To the left of this should be 47.5%, within the green area to the right of this should be 47.5%. Then if you use normal distribution table, then this value would be minus 1.96 as Z value, this will be plus 1.96 from that normal table. Please do verify it here. So, this would be minus 1.96 into sigma by root n and plus 1.96 into sigma by root n are margin of errors, and hence this is our significance area of acceptance, and to the left and right would be our rejection area. If we are taking 95%, so this would be 2.5% on one side and 2.5% means alpha by 2, alpha is 5%, alpha we know is the level of significance. Here are certain values like we are discussing. Please do verify these from the normal distribution table, Z table. When we say 90% area, so 90% area means from center 45% on right side, 45% on left side. So, corresponding to 0.45 area in the normal distribution table, area 0.45, not Z value, area 0.45, what Z value you get. So, please do verify corresponding to area as 0.45, total is 90%, one area 0.45, one side. Z value you will notice it is 1.645. When one side area is 95%, you will notice from that normal distribution table in the back of the book, it is 1.96. 99% it is 2.576. So, please do verify these values. Then let us move to some examples on this and try to solve some examples on interval estimation, on point estimation. These are quite simple, that x bar would represent point estimation of mu and small p would represent point estimation of capital P and so on. Question is, Discount Sounds has 260 retail outlets throughout the United States. The firm is evaluating a potential location for a new outlet based in part on the mean annual income of the individuals in the marketing area of the new location. A sample size of 36 was taken. The sample mean income is $41,100. The population is not believed to be highly skewed. So, we are assuming it is a normal population. The population standard deviation is estimated to be $6,500, and the confidence coefficient to be used in the interval estimate is 0.95. So, here confidence indirectly he is talking about the probability, the confidence you must have should be 95%. So, what would be that interval of 95% confidence he is requiring from your side. So, here 95% confidence means that the marginal error should be 1.96, at 95% value is 1.96 into standard error. So, that would be z alpha by 2 is 1.96 here. Please do verify this from normal distribution. 95% means 47.5% on left side, 47.5% on right side. Then standard error is, you know, in case of average x bar it is sigma by root n. So, sigma we are given it is 4500, and sigma by root n sample size is 36 given to us. So, if we put that here, we get the margin of error as $1,470. Once that margin of error is there with us, then you remember the formula for standard error is formula for interval estimation is x bar plus minus margin error. So, substitute that margin error here plus minus. So, if you subtract it, please verify if it is the same value. If you add it, then it will be same 42,570. Hence, we are 95% confident that our interval that will contain the population mean will vary from the lower limit $39,630 to $42,570. So, this was the case where our sample size was 36. So, we assume using the theorem, center limit theorem, that it will follow a normal distribution and our interval estimation can be calculated in this form. Now, in case our sample size is not large enough, it is 30 or less, then we know that we apply t distribution. Then in the t distribution, we only assume that our sample is small, but the population is normal or approximately normal. So, in case of t distribution, our interval estimates will vary from x bar minus t. The only change that will take place would be from z to t here into s by root n and plus t s by root n. So, t is the tabulated value of t statistic. At n minus 1 degrees of freedom, we will have certain degrees of freedom with the help of which we will be able to identify t value and level of significance, and hence using those we can calculate the interval estimate here. I hope this is clear to all that t distribution we apply only where our sample size is less than 30. So, it is quite important looking at a particular situation whether the sample size is more than 30. More than 30 comes under large sample and less than 30 comes under small sample. Under large sample we apply z test, under small sample we apply t test. Here is an example to have more understanding how we can calculate interval estimate in case of t test. A reporter for a student newspaper is writing an article on the cost of off-campus housing. A sample of 16 efficiency apartments within a half mile of campus, resulting in a sample mean of $750 per month and a sample standard deviation of $55. So, here sample size is 16, and when we are talking about the cost of off campus housing, so the average off campus housing cost within half mile of the campus it is $750 and the variability of that sample is $55. Now he is interested in finding a 95% confidence interval estimation of the mean rent per month for the population of efficiency apartment within a half mile of campus. So, it is quite important that whatever information is there in the situation in a particular case, case set or a word problem, we try to extract that. So, he is talking about cost of off-campus housing, that is a particular situation. Sample size taken is 16. So, small n would be 16, it is not capital N because it is sample size, not the population size. Sample mean given to be is $750 per month. So, x bar is $750. Please write these given values, given n is 16, small n, x bar is 750. Sample standard deviation, so S would be $55 and confidence we need is 95% confidence. So, let us look at this. At 95% confidence means alpha is 5%, to the left of that rejection region you will have 0.025, to the right you will be having 0.025. Since the sample here is 16 only, n is 16. So, our degrees of freedom like we discussed in t-tests, whenever our data is less than 30, we have a degree of freedom. Degree of freedom here means how many values are free to take any observation. To understand the degrees of freedom, say if we take an example of average of 5 numbers, say average of 5 numbers is 50 and you can assign any value to 4 observations, only one would be dependent to have the average as 50, say average of 5 observations is 50 and say those 4 observations are, one of them is 0, another is say 1000, then 3000 and fourth is say 4000. So, 1000 plus 2000, 3000 plus third say 4000. So, it is 7000 in total and one observation is 0. So, if we need to have an average of 50, so the total should be 250 divided by 5, hence the average would be 50. So, automatically the fifth observation it will takes its own value in negative out of 7000, so that the total is 250. So, the fifth observation would be 7000. So, the fifth observation should be 7000 minus 6750. So, 7000 minus 6750 will make the total of 5 observations as 250 and by 5 average x bar as 50. So, when we were talking about those 5 observations, the idea, the reason behind taking that example is 4 observations are free to take any value. So, if there are 5 observations, 4 were free to take any value, hence whenever there are n observations, so 15 are free to take any value, therefore, 15 is the degrees of freedom. So, here in 15 degrees of freedom in the t distribution, at 15 degrees freedom, this is just a small portion from the t table. Please look at the t table at 15 degrees of freedom and at this 5% level of significance. In one side, if it is 0.025 in the upper tail, then t value is 2.131. Please do verify this t value, because this would be needed while solving situations, while calculating a confidence interval. You must know how to identify this yourself. Please do verify this. So, once we have this value of the t statistic, we will use that value in calculating the interval estimate. We were given, let us look at what was the x bar value. X bar value was 750 per month. Then use that x bar value here. T value from the table, we have 2.131, we just got it. Sample standard deviation was given to be 15, sample size was 16. I hope it is clear. So, put them one by one, calculate it, you will notice it is marginal error now, 29.30 is the marginal error, which will add and subtract. So, once we add and subtract, hence we can say if the average from the sample is 750, then to be 95% confident, the range that we can take is from approximately 720 to 779. That 95% of the students who are staying off campus will be paying this much. I hope this is clear. The meaning of this interval estimation is 95% students who are staying off campus within half a mile distance of the campus will be paying from $720 to approximately $780. Remaining 5% may be paying any amount lesser than this or more than this. So, that is the meaning of interval estimate, and this where we have applied this interval estimate, this we have applied here in case of T distribution, where the sample size was less than 30, and before that we applied in Z distribution where the sample size was more than 30. In the same way, we can apply it in case of population proportion. Proportion, you understand, is the fraction of population having certain characteristic of interest. So, again since the idea is clear to you, in case of proportion also the interval estimate will look like this. We can go to the general formula. It will be statistic first plus Z value. In case of proportion, we assume the population is large enough. So, always we apply Z there in case of proportion, and hence the general formula for interval estimation would be statistic means small p plus minus the margin of error. Margin of error would be Z into standard error of proportion. So, only difference in large sample and proportion interval estimate would be standard error will change, and you remember the standard error for proportion. In case of x bar, the standard error was sigma by root n, and in case of proportion the standard error was pq by n under the root. So, let us see how we can apply it in this particular situation to calculate interval estimate of a population proportion. Here is an example of political science inclusive specialize in voter polls and survey designed to keep political office seekers informed of their position in a race. Using telephonic surveys, PSI interviews ask registered voters who they would vote for if the elections were held that day. For example, these days elections are quite close. So, it is a quite useful example here. So, how do they ask respondents which party would they vote for? So, here is the situation, they ask it telephonically. Now, in a current election campaign, PSI has just found that 220 registered voters out of 500 contacted favor a particular candidate. Say assume any XYZ candidate, out of 500 that you have contacted, 220 are favoring that particular candidate. So, 220 out of 500 is the proportion of respondents who are favoring it. I hope this is quite important to understand here, that the information given to us is not an average information. It is a certain characteristic, certain fraction of respondents. 220 out of 500 would be a fraction certainly. So, 220 respondents out of 500 are favoring a particular candidate. So, it is the proportion of respondent who are favoring a particular candidate. So, this will assume this will consider as small p, not x bar. So, small p is given, 220 are favoring. So, how many are not favoring? So, 280 are not favoring out of 500. So, p 220 is favoring, and you remember in case of proportion we had p and we had q. Small p, small q were the sample statistic. So, q here would be 1 minus p means 280 out of 500, and capital P, capital Q were the population proportions. Population proportion here is not given. So, we will only be using sample proportion. PSI wants to develop a 95% confidence interval estimate for the proportion of the population of registered voters that will favor the candidate. So, this information is sufficient to have the proportion of the population of registered voters that will favor the candidate. So, how we can have that interval estimate? So, can you give it a try? See if you can. Let's look at the solution. So, here interval estimate would be, please relate with the general formula of interval estimation. The general formula says, first we have a sample statistic plus minus margin of error. That is, I hope, very easy to remember. Sample statistic plus minus margin of error, and margin of error is what? It is the probability, the z value into standard error. Standard error in case of proportion is p into q by n. Q means 1 minus p by n. So, substitute those values here. Small p is 220 by 500 C here, and q means 1 minus p, automatically that will come here 280 by 500 and 0.44. Here it is, what is the given level of significance? They have mentioned 95% confidence level. Even if it is not mentioned, in general we assume that level to be 95%, which is quite frequently used. We will use that 1.96 value here, 0.44 into 1 minus 0.44 by 500. So, value will come 0.44 plus minus 0.435. Hence, if the lower limit is 0.3965 and 0.4835. So, hence you can be, what would be your conclusion here? What would be the final understanding of this interval estimation? So, you can say that particular agency PSI would be 95% confident that the proportion of all voters that favor the candidate is between 39.65% to 48.35%. So, 39 to 48% candidates will lie in the 95% confidence limits. I hope that is clear. So, what we have discussed till now, we have discussed the estimation. In estimation, we discussed the various 4 characteristics of a good estimator. We discussed unbiasedness, we discussed unbiasedness, and efficiency, sufficiency, and consistency. So, for any estimate to be a good estimate, those 4 characteristics should be fulfilled, and then we move to the types of estimation, that includes point estimation and interval estimation. Point estimation is the value of the statistic itself. Point estimation is the value of the statistic itself from the sample, which is used to represent the population. If we consider that value as it is, means we are using point estimation. But if we try to have certain range with certain degree of confidence, that means we will be using interval estimation. And then in interval estimation, we can use that interval estimation for average. We can use that interval estimation. Average means when n is greater than 30, when n is less than 30. In case of greater than 30, we apply z test. In case of less than 30, we apply t test, and in case of proportion also we are applying z test. This is just a quick summary that you can keep in mind while applying estimation. The again general formula here, alpha by 2 is only used how much we are moving on the left side with our marginal error, and how much we are moving on the right side. So, this green is the interval estimation. 90% means 90% of the time population parameter will lie in this, and 10% of the time population parameter will lie outside this. So, this is just the complete summary that you can remember in case of average, in case of sample size more than 30, in case of sample size less than 30, do use t distribution for the probability, and with the certain given sample size, you can calculate the degree of freedom means n minus 1, and you can have the tabulated value of t, use that here. And this will be studying in chi-square. It is not required right now as far as related to variance the confidence interval is concerned. You can only have in case of mean and greater than 30 and less than 30, and in case of proportion. Then moving further, the book I recommend, please use the book Statistics for Management, Levin and Rubin. Recent Indian edition is in the market, that is quite good. In addition to that, if you would like to use, you can use Statistics for Business and Economics by Anderson, Sweeney, Williams, and otherwise. You can also use for more information Business Statistics by Ken Black. So, we are through with estimation, and in the next lecture we shall be taking testing of hypothesis, where we would like to test the validity of our assumptions. We may have certain assumptions about the population parameter. So, whether those assumptions are correct, or those can be accepted, or those can be rejected. So, we will be taking that in next session. That is it from my side for this session. Thank you.